minus 1 whole cube, which is minus 1. Minus 1 into minus 4 becomes plus 4. So this is the cofactor. Cofactor is nothing but just assigning the sign for a particular position of an element. After finding the cofactor of all the elements, if you write that cofactor in one matrix, that is called as cofactor of a matrix A. When the determinant value is 0, it is called as singular matrix, and when the determinant value is not equal to 0, it is called as non-singular matrix. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In today's session, we have many topics to discuss, that is minors, cofactor, adjoint of a matrix, singular and non-singular matrix. Let's see what is minors. So what is the minors means? For example, let me take a 2 cross 2 matrix 1, 3, 2, 7. So minor is an element which is obtained by deleting the ith row and jth column on which the element aij lies. So if I take 1, delete the row and column containing 1, what is the remaining element? That is 7. So therefore, the minor of 1 is 7. We consider it as minor of 1 is 7, like this. And suppose I take 7 here. So 7 means we have 1, 2, 3, 7. Similarly, if I take 7, what is the minor of an element 7? Delete the row, delete the column containing 7 and write the remaining element. So that is the minor of 7. So here the minor of the 7 is 1. But in case of 3 cross 3 matrix, consider 1, 3, 0, 0, 2, minus 1, 1, 1, 0. Now, what is the minor of element 3? I want the minor of element 3. So, what does the minor definition says? Delete the row and column containing 3. So, here we have 4 elements. So, we have to take the determinant of that element. So, therefore, the determinant of this element is 0, 1, minus 1, 0. Or we can directly write 0, 0 is a 0, minus 1 into minus 1 becomes minus 1. So, therefore, the answer is 1. So, therefore, the element of 3 or the minor element of 3 is 1. So this is how we are going to find the minor of a particular element in a matrix. When it is a 2 cross 2 matrix, it is very easy to find, and when it is 3 cross 3 matrix, you should take the determinant values of remaining element when the element containing ith row and jth column is completely deleted. So, and it is always denoted by capital Mij. So, for particular element Aij, we know A11, A12 means first row, first column, first row, second column element. So, for that particular element in a particular row or column, every element is denoted by Mij. Next is cofactors. Cofactor is nothing but just assigning the sign for a particular position of an element. Now, let me show with the 3 cross 3 order matrix. So, here let me take 6, 0, minus 5, 2, 1, 3, minus 1, 2, 0. So, this is the determinant we have. We have to find the cofactor of the element 2. What is the minor of 2? First, we need to find out the minor of 2, that is minor. So, element here, this is in the second row, first column. So, this is the element A21. So, therefore, minor will be M21. So, this is the minor. So, delete the row, delete the column containing 2, and it is, the minor is 0, 0 is a 0, minus 5 2 is a minus 10, which becomes plus 10. So, therefore, this is the 10. So, minor is M21. But what is Aij? Aij depends on the sign of the I and j. So, since this is 2 plus 1, so the cofactor A21 is equal to minus 1 to the power 2 plus 1 into 10. So, minus 1 whole cube is minus 1, minus 1 into 10 is minus 10. So, this is how. So, for the minor, a particular sign is assigned to find it as a cofactor. So, this is how we are going to find the cofactor of a particular element as well as the minors of a particular element. Now, here Write the minors and cofactors of the elements of the following determinants. So here we have 2, -4, 0, 3. So let me take this as A11, A12 and here this is A21, A22 element. Okay, I am writing the minor of 2, minor of -4, minor of 0 and minor of 3. So A11, so minor is M11 and A12 minor is M12. And for A21, minor is M21, A22 is M22. So these are the minors. So now we have here, for 2 it is 3, for -4 it is 0, and for 0 it is -4, and for 3 it is 2. So cofactors means A11, A12, A21, A22. Clearly we can see here, by adding I plus j, you can just directly write positive and negative sign. 1 plus 1 is 2, so -1 whole square is 1, so this is plus. And the minor is 3. So this is minus, so we can't write -0 because 0 is neutral, so the answer is 0. So 2, 1 will be -1 whole cube, which is -1. -1 into -4 becomes +4. So this is the cofactor. Next is 2. 2 and 2 are 4, -1 whole power 4 is again positive, so it is 2. So these are the cofactors and minors of this determinant. Next, 1 0 0 0 1 0 0 0 1. So let me write all the minors first. So M11, so we have 3 row 3 column, M11, M12, M13. Similarly, M21, M22, M23. Next we have M31, M32, M33. We are just finding the minors. How to find the minor of 3 cross 3 determinants? Just suppose if you are taking 1, delete the row and column containing 1, take the determinant value of the remaining element. So this is directly 1 minus 0, which is equal to 1. Next for 0, delete the row and column containing this. So it is 0 minus 0, clearly 0. Next for 0, delete the row and column containing it. So 0 zeros are minus 0, again it is 0. Next for M21, for this one, so delete the row, delete the column containing 0. We have 0, 1, 0, 0. Again the determinant value is 0. Next we have 1. So delete the row, column containing 1. We have 1 ones are 1 minus 0, which is 1. Next is for 0, delete the column and row. Next we have 1 zeros is 0, 0 minus 0 is again 0. Next we have for 0, so 0 again the value of the determinant for M31, it is 0. Next for 0, for this 0, delete the row, delete the column, the value is again 0. Next for the last one, delete the column, delete the row, 1 ones are 1 minus 0, so which is 1. So these are the minors of the particular elements. Now let's write the cofactor. Cofactor is A11, A12, A13. Similarly, A21, A22, A23, A31, A32, A33. So remember the sign always, it's easy. So plus minus plus, and here put accordingly. So we have plus minus plus. So that is when you add it odd number, it means negative. When you add it is even, means it is positive, and here it is negative. So we have positive, negative, positive. When it is 0, no need to write the plus or minus symbol here. So and write the particular minor element, it is 1. So here it becomes, so 0. The value is 0 here. Here it is 0 again. So for this value, it is equal to 0. No need to put sign there. Next we have 1. Here it is 0. For this also it is 0 and it is plus 1. So these are the cofactors. So first assign the sign and write the minors with that sign. So that will become the cofactor. Next we have 1 0 0 3 5 minus 1 0 1 2. Let's write M11. So next below that only I'll write A11. Next I'll write M12, A12. Next M13, A13. So first let us find these. So minor of 1. So delete the row column containing 1. We have 5 2s are 10 minus 1 into minus 1 is plus 1. So it is 11. 1 plus 1 is 2. So it is positive. So the answer is plus 11. So the cofactor. Next is minor. So delete the M12 means first row second column element. For 0 delete the column, delete the row. So we have here 3 2s are 6 minus 0 which is 6. What about the cofactor? 1 plus 2 is 3. So if it is 3, I plus j is 3 means we have negative sign. So it is minus 6. So therefore the cofactor is minus 6. Similarly for M13, that is this 0, we have 3 1s are 3 minus 0 which is 3 and the cofactor is also 3. Next we will take M21, A21, M22, A22, M23, A23. Now M21. So second row first column element, delete the row, delete the column here, then it is 0 to the 0 minus 0 which is 0. If minor is 0 then cofactor is also 0. Next is for 5, we have 1 2s are 2 minus 0. So 2 minus 0 which is equal to 2 and this is positive so cofactor is also 2. So minus 1 we have, delete the column, delete the row, 1 minus 0 we have. So 1 minus 0 which is equal to minus 1. 2 plus 3 is 5, minus 1 whole power 5 is minus 1, minus 1 into 1 is minus 1. Next we have M31, A31, M32, A32, M33, A33. So for 0 now, delete the column, delete the row, 0, 0 which becomes 0. If this is 0, cofactor is also 0. Next we have for 1, delete the column, delete the row, minus 1 minus 0. So minus 1 minus 0 which is minus 1 and 3 2 is again negative so it becomes 1. Next for 2, delete the row, delete the column, 5 minus 0. So it is 5 minus 0 which is equal to 5 and the answer is 5 here. So this is how we are going to write or find the minus and cofactor of each and every element inside the value of inside the determinant. Next. So there is an important thing to note that sum of the product of elements of any row with their corresponding cofactor is equal to the value of the determinant. So that is when you multiply A11. What is A11? So this is A11, A12, A13. Similarly, this is A21, A22, A23. Similarly, this is A31, A32, A33. So when you multiply A11, this is what A11 with A11 and A12 with A12 and A13 with A13. So let's see it now. That is we are multiplying 1 into 11 which is 11 plus A12 is 0. 0 into minus 6 which becomes 0 and the last A13 is again 0. So the value is 11. This is always equal to the value of the determinant. Now let us find the value of the determinant for this. If you find the value of the determinant here clearly, see here, let us find the value of the determinant. So 1 into, when you take the determinant it is 11 only. So and the other two elements are 0. So this is always equal to delta. Similarly, when you multiply A21 with A21 and A22 with A22, A23 with A23, the value will be again 11 only. That is equal to delta only. Similarly, when you multiply the third row elements with the cofactors of it and add it, the value is always equal to the delta. So this is one rule or speciality, that is when you multiply the particular element with the cofactors of particular row, the value is always equal to delta. But when you take it vice versa, that is when you multiply any element with other cofactors, other row cofactors, then the value will be equal to 0. Let us check this also. Now we have A11 as 1. So let me prove this now. So let me take A11. A11 is 1. Now let me take A21. What is A21? That is, we are going to take the capital A21, which is 0. Next we have A12. So 0 into anything is 0 plus 0 into anything is 0. The value is 0. So that is, when you multiply the element of one row to the cofactors of the other row, the value is always equal to 0. But when you multiply elements with their cofactor and add it, it is always equal to the value of the determinant. So next is a cofactor matrix. What is cofactor matrix? We know that for every particular element, we will find a cofactors, and writing all the cofactor in a matrix, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So we know that for every element, we are going to find the minus, and after that assigning positive or negative, we'll get a cofactor. And writing all the cofactors in a matrix is called as cofactor matrix. So after finding the cofactor of all the elements, if you write that cofactor in one matrix, that is called as cofactor of a matrix A. Next is adjoint of a square matrix. So adjoint of a square matrix is very simple. We know that cofactor matrix is nothing but finding all the cofactors A11, A12, A13, and here it is A21, A22, A23, A31, A32, A33. So when you transpose it, if you take the transpose, then it is A11, A12, A13 here, A21, A22, A23 here, A31, A32, A33 here. That is, transpose of a cofactor is nothing but adjoint of a matrix A. So thus, transpose of a cofactor matrix is known as adjoint of a given matrix. So therefore, to find the adjoint of a matrix, you should know the concepts of minus, cofactor, and how to write those cofactor in a matrix, and after that, transpose it, you will get an adjoint of a matrix. Next is find the adjoint of a following matrices. So here the determinant A is given. Now to find the adjoint of this matrix, so interchange the principal diagonal element. So that is, adjoint A is equal to, interchange these two, that is, we write 4 and 1, and change the sign for this element. So here change sign for this, and this is interchange. This is the shortcut method to find the adjoint of 2 cross 2 matrices. The other thing is find the cofactors and write the cofactors, take a transpose which is one and the same, and this is the shortcut method. So here we are going to write -2, -3. So this is the adjoint matrix of a given matrix here. So what is the other way to find? What is the cofactor? A11, A12, A21, A22. We are going to find it here. So what is the minor of 1? It is 4. So 1 plus 1, so 4 here. What is the minor of 2? It is 3, but 1 plus 2 is minus, so -3, and here it is -2, and here it is again 1 here. Now we have to write this in a cofactor matrix. So cofactor of A is equal to A11, A12 is 4, -3, -2, 1. Now what is adjoint? Adjoint is, you should transpose this matrix. Transpose means writing rows into columns. So they are one and the same. Clearly you see 4, -2, -3, 1. So instead of doing all this, just use this hint, interchange the principal diagonal elements and change the sign of other diagonal element. That itself is the adjoint of a given matrix. Next. So here also we are going to find out the adjoint of a matrix. So here we can't use any shortcut method. We have to find all the cofactors and then find the adjoint of a given matrix. So let me find A11, A12, A13. Next here A21, A22, A23, A31, A32, and here A33. So what about the sign? Use the sign. as indicated. So this is always plus, minus, plus, and here it is minus, plus, minus. So here plus, minus, plus. If it is 0, no need to substitute the sign. So now we have to take the minors of each. So what is the minor of 1? So it is 2051. That means 2 ones are 2 minus 0. So the answer is 2 here. Next, minor of 2. Delete the row, delete the column. Minus 1 into 1, minus 1 minus 0, which is plus 1. Next, for minus 2. So for minus 2, delete the row column. Minus 1 into 5, minus 5, minus 2 2s are 4. So the answer is minus 9. Next is A21. For A21, delete the row, delete the column. 2 1s are 2. Minus 5 2s are minus 10 becomes plus 10. But the answer is minus 12. Next, for 2, 1 1s are 1 plus 4. So the answer is 5. Next, for A23, delete the row, delete the column. 1 5s are 5. Minus 4, which becomes minus 1. Because outside we have minus. Next to 2, delete the row, delete the column. 2 minus 2, 2 0. 2 zeros are 0. Minus of minus 4 becomes plus 4. So 0 plus 4, it becomes 4. Next we have for 5, delete the column, delete the row. 1 0 is a 0. Minus 2. So 0 minus 2, which becomes plus 2. Next we have for the last one, 1 2 is a 2 plus 2. So here 2 plus 2 is equal to 4. Now write the cofactor matrix of A. What is cofactor matrix of A? A11, A12, A13, A21, A22, A23, A31, A32, A33. That is writing all the cofactor elements. Just write it. What are those? It is 2, 1, minus 9. Next, minus 12, 5, minus 1. Next, 4, 2, 4. So this is cofactor of a matrix. Now let us write the adjoint. What is adjoint? Adjoint A is equal to, you should transpose this matrix. So interchange rows into columns. So 2, 1, minus 9, minus 12, 5, minus 1, 4, 2, 4. So this is how we are going to find the adjoint of a 3 cross 3 matrix. Thus, substituting the sign and finding this minus, we can find the cofactor matrix element. Then after transposing cofactor elements, we can get adjoint A. So we can also write adjoint A directly without writing cofactor matrix also. That is, since you know all the elements A11, A12, A13, instead of writing A11, A12, A13 in a row form, if you write all the elements in a column form, that itself is a adjoint matrix again. So no need to write cofactor matrix to find adjoint. So if you want to write cofactor, transpose it, then you can get the adjoint of A. So now we have known how to find out the adjoint of a given matrix. The last one is singular and non-singular matrix. What is this singular and non-singular matrix? So if a square matrix A is said to be singular, then the value of the determinant will become 0. And a square matrix A is said to be non-singular if determinant A is not equal to 0. I'll take an example of 2 cross 2 matrix. So see here. So 3, 1, 6, 2. So find the determinant of this. What is the determinant of this? 3 2s are 6. Minus 6 1s are 6. See here the value is equal to 0. So this is called as singular matrix. So let me take one more example. 1 3 2 7. So what is this? 1 7s are 7 minus 3 2s are 6. So this is equal to 1. So the value is not equal to 0. So this is non-singular matrix. Thus, when the determinant value is 0, it is called as singular matrix. And when the determinant value is not equal to 0, it is called as non-singular matrix. So in today's session, we have learned how to find the minors, cofactor, and how to write it in a cofactor matrix, adjoint matrix, and finally singular and non-singular matrices. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.